To begin this week, on Tuesday, we learned about frequencies. We learned about superconductors and how they have zero resistance. We learned about p-type, n-type, with bonds, for example, silicon and gallium, as well as silicon and arsenic. There's forward bias and reverse bias. Is accelerated charge. We were given ultraviolet light, and we needed to find the frequency range, the wavelength, something similar in size, and a natural source, a man-made source, what charge is accelerating, and cool applications. For frequency range, we got 7.5 times 10 to the 14th hertz, all the way up to 3 times 10 to the 16 hertz. For the wavelength, it's 400 nanometers to 10 nanometers. Something similar in size is a mycoplasma bacteria. A natural source is the sun. A man-made source is a black light. The charge that is accelerating is an outer shell electron, transitions very high to low. Cool applications, it's used for crime scene inspections. It's used to inspect currency and also for scorpion detection. For Thursday's class, we built this device where we put a triangular reflective triangle on this 360-degree compass, and we shined a light to it. We had to make a single beam, and what we did was when that single beam hit, it made reflection. So at the beginning, for 0 degrees, we got a reflection of 0 degrees. As we moved the compass, we moved it to 10 degrees, and we got a light that bended to 5 degrees. Then we continued with 20 degrees, and it turned, and it gave us a reflection of 12 degrees. So when the light went in at 30 degrees, came out 18, 40, the bend was at 25 degrees, and so on. As we continued, we tried the single light on the curved side of this triangle, and it gave us, for 10 degrees, it gave us 15 degrees out. 20 degrees in, gave us a bend of 30 degrees out. For 30 degrees in, it gave us a bend of 50 degrees out. For 40 degrees in, it gave us a bend of 70 degrees out. Things like that. Then we continued by putting more than at least one beam of light to hit the flat surface and the curved surface, as you can see on this picture. And we got different degrees of bend, of dispersion, pretty much, which means when colors bend, we got different degrees. Then we continued by adding different objects, like this crystal clear half circle, and it showed how blue light and red light bend, and it showed a different kind of reflection due to the surface and the material of that half circle. For Arduino, I did on chapter 5 the mood cue with the motor, with the servo motor that would turn, as well as the potentiometer that you could turn and change the voltage. Then we continued with chapter 6, the light theremin, which would make a buzzing noise when you would touch the photoresistor, and the buzzing noise would change frequencies and things like that. Then at the end, I finished off with chapter 7, the keyboard instrument. Pushing each one of those buttons would give a different key noise, and you can actually play a little song if you really get clever with it. As you click each switch, that's what they're called, switch, you're able to cause a different noise to come out of the speaker. so a different kind of tone. One last thing, we also experimented with polarized lenses on Thursday, as well as also looked at light and how light can be split, as well as seeing a gas make the, as well as notice the light spectrum coming out of the gas.